So what I want to think about in this lesson is the question, what is the universe made of? What's the universe made of? So what we can say, so we have this theory that we had this event that happened, which was known as the Big Bang. And that happened roughly 13.8 billion years ago. So 13.8 billion years ago, and that's a hell of a long time. So the Big Bang. So we had this Big Bang event. So at the start of the big, like at the just before the Big Bang, we had a tiny region in space, and all of matter, everything was compressed into this tiny space. And then what started to happen is over time, it started to expand and get bigger and bigger and bigger. So we had this Big Bang. Now, as time went on, so the temperatures were very high, were extremely high. And in these really high temperatures, all you have is like a soup of subatomic particles. Like if we remember, so we have the proton, the neutron, and the electron. And these are the subatomic particles. So this, we can say this is a proton, and then this is a neutron, just in green here. And what started to happen then, things started to cool down, and then you had atoms you had these subatomic particles, this soup of subatomic particles started to come together and form some of the basic elements. So then after a period of time, the universe is getting bigger and bigger and bigger, but you have like basic elements such as hydrogen formed. And hydrogen, as you can see, is just very simple, it's just simply a proton. And then over time, then you started to get helium, which is a little bit more complicated. You have, instead of just one proton, you have instead of just one proton, you have two protons and two neutrons. And then over time, we started to get little trace amounts of lithium as well. Lithium, as we can see here, it's the third element on the periodic table, and it's relatively simple. It's just made up of three protons, three neutrons, and then you have three electrons as well. So this kind of started to happen during the Big Bang. And if we think, like, let's say just after the Big Bang, so let's say if we kind of say somewhere around here, so after the Big Bang, if we were to look at the composition of the universe, so if we were to look at, let's say, what the universe was made up of after the Big Bang, we'd have something like this. So we would have, or we would have had, let's say 75% would have been helium. So helium, this element here, is the most abundant element at the time. Sorry, hydrogen, so I say hydrogen. And then 25% helium, which is this element here. So this is right after the Big Bang. So you can see the majority element is hydrogen at 75%, and then helium at 25%. And then there would have been a small amount of lithium. Now lithium it's extremely small, so you're talking about 10 to the power of minus 10. So that's 0.123. So we're talking something like that. That's percentage. That's how much lithium. So it's very, very trace amount, and almost we can pretty much ignore it. So this is just straight after the Big Bang. Then after time, so you can imagine you're going to have these big clouds or these big gas regions of hydrogen, and these are what are known as nebula. So nebula, so they're basically just these big massive clouds or pockets of clouds of helium, or sorry, hydrogen should I say, and you can think of them like just hydrogen atoms, just simply protons, just all that kind of hanging around. And you would have had like, so this was your setup. So you have regions, you have pockets, and you'd have space with nothing in it, and then pockets of hydrogen. And then what started to happen, and we'll talk about this in a little bit more detail in another lesson, but these hydrogen clouds started to come together and they started to create stars. So if we think about our star, so 4.6, so if we say roughly about 4.6 billion years ago, our sun was born. So this hydrogen cloud started to come together, and hydrogen it started to produce. So the hydrogen was converted, let's say, into helium. So what happened is then the composition then of the universe. Remember, this is the composition of the early universe just after the Big Bang. And then if we take, let's say, so around this time, 4.6 billion years, if we look at the arrangement, we have something kind of similar, but some of these dimensions have changed. So imagine I have something that's like this. Oh, no. So we have 71.6% hydrogen. So we can see here that the amount of hydrogen, the percentage of hydrogen has reduced. So you can see that here. So the amount of hydrogen has reduced. This is with the creation of this star. And then if we take, so helium would have been at, let's say we just draw a line like this. So helium would have been roughly about 27%. So 27%. So we can see that helium here, the amount of helium has actually increased by about 2%. And then what you have then in here are all the other elements. So this percentage here then, this is so 1.4%. So it's all the other elements. And they called sometimes they're called heavy elements. So we have this kind of evolution, if you like, this chemical evolution, and we can see that what's changing here. So the amount of hydrogen is changing. So the amount of hydrogen is reducing, the amount of helium is increasing, and then we start to get all of these other elements, the heavier elements start to form. So if we think on the periodic table, so we have mainly this, we have some of this, so this starts getting converted into this, we have little trace amounts of this, and then after a period of time, after our sun is born, roughly 4.6 billion years ago, we start to get, like let's say, on a whole, the 2% composition is made up of these other elements here, all of these other elements. And if we, let's say, fast forward to today, in today's age, let's say today, so this is, okay, so if we take down today then, which is roughly about 13.8 billion years. What do we have 13.8 billion years? So we now have, let's say, 2% heavy elements. So this figure up here has increased to, so in the time that, from, let's say, from 4.6 billion years up until now, 13.8 billion years, in that period of time, which is a huge period of time, the amount of the heavy elements, the number of heavy elements has increased, and that's gone from 1.4% up to 2%. And this 2% might seem, in comparison, let's say, to the overall composition of the universe, might seem very, very small. It is like a relatively small amount in comparison to the other constituents. But within this 2%, we have, for example, all of the planets, moons, we have all of life that's on this planet, and everything that you see around you is made up of this 2%. So it's no, like, there's an awful lot that can happen, let's say, within that small 2% of elements that were produced. Now, let's say a chemist, when we look at a periodic table, this is what we look at. This is the modern periodic table. But for astronomers, what they actually like to look at, they have their own simple table, and it's relatively simple, and I'll just give you an idea, like the way that they look at it. So you have something like this. So they have, so element X, element Y, and then element Z. So if we think about what's element X going to be, it's going to be hydrogen. If we think about what's element Y going to be, it's going to be helium. And then if we think about what everything else is, it's all of these heavy elements, every other element except hydrogen and helium. So this is basically like what the universe is made of. So after the Big Bang, we have, so during the Big Bang and the seconds after the Big Bang, we generally have a massive soup of subatomic particles such as protons, electrons, and neutrons. Things are so hot that these can't actually come together and form atoms. But what happens is over time it starts to cool down, and then we start to get simple elements, like a simple element like hydrogen formed. Hydrogen then, over a period of time, it starts to come together and produce stars. So for example, our star was born 4.6 billion years ago. So hydrogen, basically what happens is hydrogen gets fused together and it turns into helium. So we get, from hydrogen, we start to get helium. And what happens then is, over time, then helium starts to get fused together and we start to get more of all of these other heavier elements. Some of the heavier elements, particularly, let's say, from all the way up to iron, for example. So all of these elements here, all the way up to iron, up to this 26th element, they get produced by, for example, hydrogen and helium fusing through fusion reactions that happen inside in the core of stars that are formed. So after the Big Bang, this was the composition of the universe. So what was it made of? It was mainly hydrogen at 75%, and then some helium started to get produced as stars were produced. Then fast forward, let's say 4.6 billion years after the Big Bang, our sun is born, for example, and the composition changes. So we see that the amount of helium has dropped, the amount of hydrogen has dropped, should I say, and that the reason it's dropped is because it's getting converted into helium. and we can see the amount of helium has increased. And what starts to happen then is helium then starts to get fused together, and it starts to make up all of the other heavier elements. So we get, let's say, the composition of all of the other elements is roughly 1.4%. That's all of the other elements that are considered heavy elements. These are all the elements heavier than hydrogen and helium. So remember, so you have hydrogen and helium, and then all of the heavy elements. That's the way astronomers look at it. And then fast forward, then let's say 13.8 billion years, and that's roughly around today. So what has happened is this composition has changed again, and we have all of the other elements has gone from 1.4% to 2%. So we get 2% of all of the other elements. And this is what we mean by chemical evolution. So we get this evolution or life cycle, if you like, of these elements. So that's kind of just a rough idea of the arrangement of some of the arrangement and the composition of the universe back during this time. So hopefully that makes sense, and we will start to have a look at this in a little bit more detail in the next lesson.